In this part, I'll look at IPv4 addresses. Despite the fact that IP version 6 networking is now accessible and being used, IP version 4 networking will continue to exist for a very long time. In this video, I will first discuss what IP version 4 is, followed by an explanation of what an IP version 4 address is. It is critical to comprehend what creates an IP version 4 address. They launched IP version 4 when it was originally developed. The concept of classful networking. Even though this concept has become depreciated over the years, it is still important to understand how it works to have an understanding of IP4 version. I'll then look at the subnetting procedure. Subnetting is the process of separating a big network into smaller pieces. Finally, I'll have an examination of private addresses. Private addresses are IP addresses that you can allocate however you see fit. You see suitable within your company. The fourth version of the IP is the IP protocol. It is the default protocol for the internet and by far the most popular protocol in use today. Version 5 of the IP protocol was never implemented by the internet, but IP version 6 is now being utilized. Nonetheless, IP version 4 will be in use for a long time. Time is approaching, thus it is critical that you grasp the process. Consider the following to learn how the IP version 4 protocol works. The IP protocol and the TCP protocol combine to give a comprehensive network solution. TCP is in charge of keeping messages alive in order and retransmission of data when it is lost, but the IP component is just responsible for transporting packages from one site to another. IPv4 addresses are 32 bits in length. To facilitate reading, they are broken into 4 octets of 8 bits separated by dots. As an example, 192.168.0.1. An IP address identifies your computer and allows other computers to communicate with it. Yours. Consider it like a phone number. Telephone numbers have area codes, although IP addresses do not. Addresses have network IDs to help separate and organize your network into logical parts. Initially, all networking was classified. These classifications ranged from A to E. The number of computers that could be on the network was regulated by the class. These networks may be subdivided into smaller portions through a technique known as subnetting. Version of IP4, since it was originally introduced, has been improved and developed. The system of classes imposed constraints on how networks might be created. Classless networks have since been added. It allows you to alter the design of networks. They introduce a mechanism known as supernetting. Enables the combination of many networks. I'll look at any of these aspects individually, but let's start with class networks, often called as classful networking. Originally, all IP addresses were allocated according to a class. The class use defines how many hosts may be deployed on this network. Today, classless networks are more frequent, which I shall discuss later. The remnants of classful networking still exist today and often used in the discussion. It is a vital issue to understand in terms of networking. The first class, Class A, may accommodate 16,777,214 hosts. These are offered on 126 different networks. The network and host IDs must not include entirely zeros. For a loop back, the 127 network is inverted. You are pinging your local machine if you ping any addresses in the 127 network. This is being used for testing. For a broadcast, the last host ID or a host ID with all ones is inverted. The next class is called Class B. This class has 16,384 networks and 65,534 hosts per network. As you can see, both classes A and B have a large number of hosts per network. The initial system allocating IP addresses based on class resulted in a large number of unused IP addresses. The Class C network has 2,097,152 networks, each with 254 hosts. This is a network, better ideal for smaller networks, although as you can see, even with 100 computers, there are still a lot of unused IP addresses on a network. For multicast, Class D is flipped. You may deliver a single packet to several machines using multicast. Class E is the final class. This class has been inverted and is no longer in use. Using classy networking generates a large number of unused IP addresses. To make use of the address, subnetting might help you save space. Subnetting allows you to divide a network into segments, into tiny pieces. It is also used to distinguish which traffic is local and which traffic is not, is for a remote network. Unfortunately, once you start subnetting your network, you must begin functioning in binary. Consider the following scenario to demonstrate how subnetting works. As the IP address, subnet mask, and destination IP address are shown in binary. When the subnet mask is shown in binary, it is clear that it is a continuous list of ones. Then a string of zeros. Ones must always be on the left and zeros must always be on the right, because the subnet can be represented by the IP address / number of bits. If I were, it would be necessary to use / notation to display the IP address and subnet mask indicated in the example. B192.168.10.100/24 as there are 24 1 bits in the subnet mask. The subnet mask is used to determine if the traffic is for a remote network or the local network. The bits from the IP address and the destination address are compared to accomplish this, but solely in relation to the subnet mask. The subnet mask in this case is 24 bits. As a result, the first 24 bits of the IP address are compared to the destination IP address. If they match, as they do in this example, the packet is forwarded to the local network. You could be thinking that I could just glance at the first 3 octets of the IP address and figure it out. To determine whether they match the target IP address in this scenario, the answer is yes, because the subnet mask is a simple one. The idea behind subnetting is you can take a larger network and reduce the size of the network. If I changed the subnet mask to the following, the subnet is no longer as easy to figure out. I've now partitioned my network by utilizing this subnet. I divided my original network into 14 smaller networks, each with 14 hosts. Network, in other words, I have allocated 4 bits of the host address to the network address of the IP address. If you take the same example, compare the subnet mask against the IP address and the same destination address, you receive the following when you enter your IP address and destination address. As you can see, the first 4 bits of the last octet do not match. Because they do not match, this packet will be forwarded to the default gateway because it is not for the local network. As you can see, subnetting provides a lot of flexibility and power for breaking down bigger networks. Smaller ones. The trade-off is that you need to start doing some binary operations. Using subnetting, you can break away from the limits imposed by classful addresses and divide. You can set up a network in any way you want. This is referred to as classless inter-domain routing. The subnetwork variable length subnet masking is the technique used. In the real world, there is no distinction between classes. Domain routing is the primary method, and classful networks are obsolete. Past. It is critical to understand the classful network because it is frequently used in literacy. As well as the real-world, classless inter-domain routers employ a distinct protocol method of indicating the subnet mask. It employs A to represent the number of bits in the subnet. As shown in these examples, /subnet mask, the number after the / represents the number of bits in the subnet mask. Using classless inter-domain routing, you can. Additionally, supernetting is used. Supernetting connects multiple networks. To create a larger network, this would be 4 if you have the networks 192.168.0.0 to 192.168.3.0. Each network is a Class C network with 254 hosts. You could combine networks if you needed a larger network. Using supernetting to combine the networking, you can combine using the subnet mask 22. 4 networks in one. This will result in a single network with 1022 hosts. As can be seen, when classless inter-domain routing is used, the IP address space can be divided up any way that you want without any of the limits imposed by classful networking. A number of addresses in the IP address space are reserved for private use. These address you are free to allocate any way you want. These addresses are not routable on the internet. A lot of companies use this fact to help with their security. If you place a would-be internet hacker cannot connect to all of your computers on a private network. directly to any of your computers. This is due to the fact that there is no routing from their computer to your computers. There are three groups of private addresses. The first is class A, which goes from 10.0.0.0 to 10.255.255.254. The next is class B from 127.16.0.0 to 172.31.255.254, and 192.168.0.0 to 192.168.255.254 for class C. All of these, you are free to use the addresses however you want and route them within your organization any way that you want. Just remember that they are not routable on the internet. If you start using private addresses, you should be aware of the risks. Automatic Private IP Address System. This system is used by Windows when Windows can. To obtain an IP address, do not contact a DHCP server. When this happens, Windows allocates 169.254.0.0 is a random IP address from the network. This enables the computer to exchange data over a local network. The concept behind this system is that you could connect a computer at home to a switch that has one or more computers connected to it. Using automatic private IP address, the computers will automatically assign an IP address, as well as be able to communicate with one another. However, keep in mind that these addresses are not routable on the internet. If you decide to use private address ranges on your network, bear in mind, you should avoid using this range if you don't want to get some unexpected results. Keep an eye out for IP addresses in this range. If you get an address in this field while troubleshooting, range indicates that the computer is having difficulty connecting to the DHCP server. After you've determined your network address and subnet masks, there are two more special considerations. Addresses that should be made known to you. As an example, consider the following IP address and the subnet mask. This translates to the following binary subnet and the following binary IP address. You'll notice that the host component of the IP address is shown in red with all zeros. This address is invalid and should not be used. This is frequently used as a network ID. Another invalid address occurs when the host portion of the IP address consists entirely of ones. For example, if you have the following IP address, I look at the subnet again in binary and then compare it to the IP address in binary. The host portion of the IP address is all ones. This type of IP address is employed to be broadcast. If you want to send data to all computers, use this method. On a network forwarded it to this address, it is also possible to broadcast from another computer to this address on the network. You will, however, notice that a broadcast like this will frequently be denied access to that network by the router. This is accomplished through broadcasting, as these have been used in denial of service attacks. When working out the subnets for your network and how many hosts you'll have, the usable number of IP addresses can be calculated using 2 to the power of hosts bits minus 2 is the formula. Consider the preceding example. 2 to the power of 10 minus 2 equals 1022 usable hosts. When breaking down your networks into smaller sections using subnetting, make sure you factor in some growth for your network, otherwise your network may become overburdened. Remember that even though IPv4 has been around since the 1970s, it has been developed and improved since then and will continue to be so. Be around for a very long time. Changing a company's networking is expensive. Many people will remain on IPv6 despite the lack of a driving need. For the foreseeable future, there is also a lot of network equipment. Despite the fact that, although support for IPv6 is growing, it is still limited to IPv4. If you intend to, remember that private addresses are not routable on the internet. Finally, when establishing a network expansion strategy, networks can frequently grow much larger than they were originally intended. You may believe you have enough space right now, but consider if your company decided to provide everyone with an IP-based phone, or if a major disaster occurred. Expansion. In short, IPv4 is not permanent, but it will be around for a long time. As a result, learning is worthwhile. Finally, when